Hello friends, welcome to this lecture where I will introduce to you the concept of changing the order of integration in a double integral. Now it is based on a clear understanding of the Rx and Ry regions that was explained earlier. To recapture the concept, let us look at this graphic where we have a region which is bounded by two curves, y is equal to g1x in blue, y is equal to g2x in red, and bounded by two vertical lines, x is equal to a and x is equal to b. So a region is said to be an Rx region when it is having the property that the upper and lower curves of the region do not intersect anywhere between the vertical parallels. This is what I mean by that. So we can describe this region as bounded by the vertical lines x is equal to a and x is equal to b, and then by the lower curve y is equal to g1x and the upper curve y is equal to g2x. In contrast, an Ry region, which can be considered a rotation of the Rx region, is such a region which is bounded by two curves, a left curve and a right curve. The left curve is shown in blue and the right curve is shown in red. And the region is also bounded by two horizontal lines, y is equal to c and y is equal to d. So a region is said to be Ry where it is bounded by two curves, a left curve and a right curve, and two horizontal lines, with the property that the left and right curves do not intersect between the horizontal parallels. That is what I mean. You observe that the left curve and the right curve do not intersect each other between the horizontal parallels. So let us see how to fix the limits of an Rx region. Let us look at this graphic and then try to understand. As already understood, the Rx region is such a region between two curves, a lower curve y is equal to g1x and an upper curve y is equal to g2x, and between two vertical lines x is equal to a and x is equal to b. So the x limits will be the outer limits of integration. I mean the left integral will carry these limits, and the inner integral will carry the limits y is equal to g1x and y is equal to g2x. Obviously, the order of integration will be dy dx. Now one can guess what should be the description of an Ry region. So let us once again come through the graphic. This is an Ry region because it is bounded by two curves, a left curve and a right curve, and between the horizontal parallels y is equal to c and y is equal to d. So we write the y limits as the limits of the outer integral and the x limits as the limits of the inner integral. Obviously, the order of integration will be dx dy. So, as a thumb rule, one can remember that Ry regions will have the order of integration dy dx, and Rx integrals will have the dx dy dx order. Now, why do we need a changing order of integration concept at all? For that, it is worth observing a few examples. Let us look at this integral. Clearly, the inner limits display functions of x. Therefore, these are the limits obtained from an Rx region. So therefore, the order has to be dy dx. Observe the complexity of the function sin y by y and how it's almost impossible to integrate that function with respect to y. In this second example, we have inner limits functions of y. Therefore, these limits have come from an Ry region, and therefore the order of integration is dx dy. But imagine you are integrating the function cos 16 pi x to the power of 5 with respect to x, for which we do not have analytical solutions. Therefore, this should also make you think probably a change of order of integration is necessary. This is a similar problem. These are the limits obtained from an Rx region, and the order is dy dx. And once again, e power y cube does not have an analytical integral with respect to y. And similarly this one. So these are 4 problems that I have decided to show you, because in all these problems there is one common difficulty. You cannot initiate the integration first. But if you reverse the order of integration, probably there is a hope. So in each of these double integrals, we are unable to initiate the integration process. And that could be the reason why we are thinking of reversing or changing the order of integration. But not all double integrals which are difficult to integrate can be integrated using the changing order of integration technique. It is one of the very special techniques, and a good number of problems can be solved using this process. But there are no guarantees. So this is only one of the techniques by which we can double integrate. So let us go through the process. How do you begin the process of changing the order of integration? The first thing you will do is observe the limits in the double integral. From the limits, you make out whether they have come from an Rx region or an Ry region. Of course, in order to do that, you must be extremely good in drawing two-dimensional curves given their equations. Coming to the second point, suppose the given problem is set in the Rx framework. You construct that region from the limits and see whether you can express the same region as a single Ry region, or you will have to split it into 2 or more Ry regions, so that the union of all these Ry regions will account for the Rx region. So that means, given an Rx problem, we are trying to see whether we can express the same Rx as a single Ry region or as an ensemble of Ry region. And once that is understood, it is now very straightforward. You express the given double integral with order reversed, either as a single Ry region or an ensemble of Ry regions, and vice versa. By which I mean, if your original problem is set to the Ry framework, you try to draw the region and see whether you can express it as a single Rx region or as an ensemble of Rx regions. So let's try to understand through an example. This is the first problem that I actually displayed for you. So here is a problem where the inner limits are functions of x. Therefore, these limits correspond to an Rx region. So x varies from 0 to pi, y varies from x to pi. Now let us look at how we have drawn the diagram. We start with x is equal to 0, which is a y-axis. Then we draw x is equal to pi, which is a line parallel to the y-axis. Then y is equal to x, that is a line through the origin that forms the lower curve. And then y is equal to pi is y is equal to constant, therefore it is parallel to the x-axis. So the region bounded by x is equal to 0, x is equal to pi, y is equal to x and y is equal to pi corresponds to the upper triangle which has been shaded. Now, as already decided, sin y by y cannot be integrated with respect to y. Therefore, we can try doing this by changing the order of integration. Let us see the same region as an Ry region. By this I mean the region should be seen between horizontal lines. The line passing through the bottommost point of the region and the line passing through the topmost points of the region. So clearly, x-axis will form the lower boundary and x is equal to pi. X is equal to, the line y is equal to pi, which is parallel to the x-axis, will form the upper horizontal line. Remember, in an RY region, we try to explain the region in terms of horizontal parallel lines. So y is equal to 0, y is equal to pi. Then comes describing the left curve. In this case, the left curve is the y-axis, therefore x is equal to 0 is the equation. And the right curve, which was earlier shown as y is equal to x, must now be written as x is equal to y, x as a function of y. So that is why you can see in the limits description, y varies from 0 to pi and x varies from 0 to y. So this is how the order has been reversed. The original problem on the left hand side can be seen and the transformed problem on the right hand side. And of course the evaluation is very straightforward. The integration of sine y by y with respect to x will give you x times sine y by y. Apply the limits 0 to y for x and then it gets simplified. You will end up with the integration of sine y from 0 to pi, which produces 2. So you can probably assess the context in which we are changing the order of integration. So this is an excellent example to tell how an Rx region has been converted into an RY region where the evaluation became possible. Let us look at one more example. In this case, if you observe the limits, the inner limits are functions of y. Therefore, these limits must have come from an RY region. So the y limits are 0 to 1, x limits are from 1 to y to 1. Right, so let us try to graph the region. Y is equal to 0 stands for the x-axis, which you can see, and y is equal to 1 is a line parallel to the x-axis. That can be seen. Then x is equal to y is a straight line through the origin that forms the left curve, and x is equal to 1 forms the right curve, which is parallel to the y-axis. So clearly, the region corresponds to the lower triangle. Now let us try to convert this RY region into an RX region. Let us come through the graphic and then understand the limits. This lower triangular region should now be described between vertical lines. So you draw the line x is equal to 0, which forms the left boundary, and then x is equal to 1, which forms the right boundary. So x limits are 0 to 1. Then the lower curve will be y is equal to 0 and the upper curve will be y is equal to x. Of course, in this problem, curves are all lines. So that explains the x limits and y limits. Now you can see the original problem on the left hand side converted into an Rx region where the limits are seen on the top of the screen. X varies from 0 to 1, y varies from 0 to x, and then evaluation of course is extremely simple because the integration of e power xy with respect to y will give us e power xy divided by x. 1x will get cancelled, apply the limits, and then if necessary integrate by parts, and then you will end up getting half times e minus 1. So this was an example selected where an RY region was expressed as an Rx region. Of course, the interesting problems which will follow with a lot of details are those problems where an Rx region may not be a single RY region. You may have to break it up. And conversely, an RY region may not be a single Rx region, but as an ensemble of Rx regions. So once having understood how to convert an Rx double integral to an RY double integral and vice versa, which is what we call changing the order of integration principle, what do we study after this? We'll do some detailed problems. Then changing order of integration with region splitting. This is what I was telling you. An Rx region may have to be broken as 2 or more Ry regions and vice versa. And then thinking of new reference frames, new coordinate systems. That means coming out of the Cartesian framework and going to other coordinate systems. And the moment you do that, the concept of Jacobians will enter. Then we'll talk in particular, the polar coordinate system. And then we'll talk about polar double integrals. So dear friends, this is the scope of what we are going to do in the following lectures. Of course, in an orderly manner, we will be studying problems on changing order of integration first, without splitting and with splitting, followed by the polar coordinate system and a quick review of the Jacobian and how Cartesian double integrals can be converted into polar double integrals. Hope you liked the lecture. Thank you.